Algebra Half Lesson 65 involves some proportion work and using it to do some geometry. Pretty cool. First of all, we've got a proportion here, two ratios set equal, and we've seen it with the fraction and the numerator before. We've gotten used to using red fraction bars, but here we have not a fraction but a mixed number. So what do you think we should do? Let's make it familiar. Since we're doing a lot of multiplication and division, we want these as impropers and not mixed numbers. So 4/9 times, what's that new improper? 4/7 fourths equaling how many x? 11/5 x. Okay? I can already see I can cancel across here, giving me 7/9 is 11/5 x. How do I get x by itself? Times by 5/11. Isn't this starting to get fun? Maybe? Just barely? No, maybe not. I think it is. 5/11. Any more we can do? Not that I see. Looks like 35/99 for my final answer. What's that mean? It means that x over here came to 35/99, right? That's what I just solved for. Now, we're going to use proportions today and apply them to something geometric. We have before us what shape? A triangle. And this triangle can be replicated with a simple copy-paste. Now, what if I try something? Right now, sides, angles, all the same, right? I mean, it's a duplicate. What if I bring it down to size just, let's say, about that much? Are the sides still the same size? No. Here's a challenge question you've maybe never considered. Are the angles now still the same size? The answer is yes. Does this still look like a 90-degree angle? Absolutely. We show it's equal using what we call tick marks. See, this arc just shows an angle, and this arc shows an angle, but we don't know what they're equal to or what they correspond to, match up to yet. But the angles are still equal. I'm going to say 2 tick marks for this guy, 3 for this one. And that shows that if it has 3 tick marks, they are equal, 2 equal, and 1 equal. They are in proportion to each other. If they aren't equal, but there's a relationship between them. See, these angles are equal, but we can build an interesting proportional relationship because angles with the same number of tick marks have equal measure. Sides opposite angles of equal measure are corresponding sides, meaning the side, let's say, opposite the single tick mark, this one right here, slanted line hypotenuse, corresponds to this side. They have a relationship. They aren't the same. I can't tick mark it, but I can build a proportion because of these equal measured angles. Let's say that this is worth 4, this is worth 5. This is worth x, this is worth y. I can say let's say this 2 is 2 and this is 3. Okay, I can say 2 over 3 is in proportion, is equal to 5 over y. Okay, I picked a side and compared it to a side. I picked another side and compared it to the unknown. How do I solve for this proportion? 15 is 2y. The y measure can be determined when we have a corresponding similar triangle. These triangles are called similar triangles. Can we do it for x? Absolutely. Let's use 2 to 3 again. 2 is to 3 as, stay in that same order, little triangle top. 4 is to, which one does 4 match up with? The x. 2x equals 12. X equals, right? You're going to divide these in your head. And I know x is 6. So we found out our two measures, x and y, by what? By building a proportional relationship. Since we knew that sides opposite equal angles have a relationship, they are proportional. In these similar triangles, we built a proportion and solved. If they give you measures that are a mixed number, we're ready to solve something like that too. This doesn't scare us either. So why don't you do B, do this one, and then do C, find M and P.